Yeah, so we did a bit of maths, the maths behind linear regression and regression generally, and most machine learning models. So don't be too scared or worry about that. You don't have to use that at all for now. You never have to worry yourself about what happens behind the mathematics and all of that. When you want to do any machine learning, all you need is for beginning few lines of code, not more than 10. And then additionally, you may need to do um, data preprocessing, some visualization. So you may have a lot more code, but you already know some how we do some of the data preprocessing and visualization. So the actual machine learning will not be more than a few lines of code. So what we looked at is last last week is linear regression, which assumes when we are doing machine learning, I explained last week we need our dependent variable and independent variable, or we see our x and y. We are trying to predict y based on x. So in linear regression, it assumes a linear relationship between our x and y. Meaning, I think I explained this last week. For example, when we say linear relationship, meaning if x increases, y also increases, or if x decreases, y also decreases. We can look at, for example, things that have linear relationship. For example, we can have age and experience. They have a linear relationship mostly. Yeah, when the older you are, then the more experience you have of the world. So this is linear relationship. But in most instances, we may not have linear relationship. We may have relationships that are not linear, meaning it's not all the time that when one increases, then the other decreases. Then when you try to fit it with linear regression, uh, you will not have a very good model. Yeah, it works only on instances. It will work only for instances that you have a linear relationship. So that is where we have, that is when we need to have methods that take into account nonlinear relationship between our variables. So if we are to not disturb ourselves about the mathematics of it, maybe I can say a bit. Uh, um, Logistic regression uses the polynomial equation as a base function. You remember I said linear regression uses the linear equation, which is y is equals to mx plus c. Most of you may remember this even from right from your secondary school. So logistic regression uses the polynomial equation, fitting it as a polynomial to do that. I think we have it somewhere here. E regression. Is it this? Yep, this is for our normal linear. So when we want logistic, we go, oh, okay, I cannot find the equation here, but yeah, it just try to map the relationship, not as, okay, you can see here. This is, for example, how we model. In linear regression, we just have y is equals to b plus mx, or mx plus c is all the same parameters. But in polynomial regression, we assume it's a polynomial of certain degree. So instead of to have a straight line like this, we have something that can curve and try to fit in many of the data points. So that is the only difference. That is the main difference. So when you want to do machine learning, and you want to do regression analysis, if you have linear relationship, then you use linear regression. Otherwise, you can use polynomial regression. There are many other models you can use, and one way to know what the best model to use in instances. That's why we have our visualizations, right? Sometimes you can just try to do, and we even have them here, scatter plots and all other plots to see, can you from the visualization deduce which kind of data you have. The kind of data you have will determine the best model for your machine learning. So when it comes to running the programs, building the model, it's the same with linear regression. You already uh, you need to install the scikit-learn. I don't know if you know how to install. I think I told you last week. You can use the pip install scikit-learn. So it will install the library for you. Um, I'm sure we did this during our introductory classes to machine learning. But you've had classes on Conda installation, right? Installing environment and all of that.
Yes, sir.
Yeah. So yeah, so you can create an environment and then you install all your the necessary packages. So when you want to do machine learning, you have to install the scikit-learn. You can use Conda to install it, or you can use pip. If you're not familiar with pip, then you are definitely familiar with Conda. Then you can use Conda and Conda to install that. So trying to look at, so difference the only difference that you have when you want to do logistic regression is, if you remember, when we train our linear regression, we have model equals to linear regression. So here you will have model equals to logistic regression. Every other thing will be the same. No difference at all. And that's why I said you don't have to disturb yourself too much about what happened behind the mathematics and all of that. Your scikit-learn library would help you do all of that. So if it's linear regression, we just define our model as linear regression. And sometimes it's always good to build two models. You can build two models, linear regression, logistic regression, get your errors and see what work best uh, in your own case. I presume this is classification because you have accuracy precision report. That's why you have classification reports. But generally, this is what we do. Okay. I've given. Okay. Let me clarify something. Um, Logistic regression. Please remember this very well. It's a regression task, but it's used as a classification problem. So in logistic regression, um, it uses a smoothing function to map the output. You know, in regression, we are trying to predict a number. So in logistic regression, it has a mapping function that makes our number either 0 or 1 after a certain threshold. So meaning, I think I've seen the image here. Yeah. So meaning we can predict anything in between this. This is our linear regression, and we're predicting numbers like the age of what people or whatever. But when it comes to logistic regression, we are predicting numbers, but then it have a function that makes whatever we have either 0 or 1. So meaning we can have at the end only two outputs, even though it's a continuous numbers that we get, but we can have only two outputs, 0 or 1. So that's why logistic regression is used as a classification algorithm. Even though we are predicting numbers, not distinct classes, but in reality, what we are doing is at the end, we are just having two classes, 0 or 1. And that's why when you want to evaluate logistic regression, when you want to evaluate logistic regression, you use classification report, what we use normally in classification problems. So I will stop sharing my screen, take questions, then I will take you to, we see some examples from VS Code, something I have from previous. Okay, I can see there is no question, so I will share my screen. I have to close this. Okay, a minute. Why cannot find my VS Code? So can you see my screen?
Yeah, it's visible.
Yeah. So I'm going to use a different example from what you in your in our repo. We have only one example of the pumpkin that we saw last week. Okay. Because of this question, let me paste the exact how you install scikit-learn. So if you are installing, I'll paste it. If you are installing it with pip, you can do pip install scikit -learn.
We
Exactly.
can't see what you're typing, sir.
Huh?
We can't see what you're typing.
No, I typed it in the chat. So
Okay.
yeah. So you type that exactly. And if you are if you have pip installed on your in your computer, if you don't know how to install a library, you can just search on Google pip install, and then you just mention the name of the library or whatever. You will see the pip page from pip.org that just uh, makes it easy for you to do that. So we'll see a number of regression models here, and then I will explain as much as I can. It will be very easy. We will not do much. This is a data size about, unfortunately, non-alcoholic wine quality, and then these are the properties. So you know how we do our data that head. We have our data frame to import the data. We see the top values of the drink. So these are just properties. And then we are trying to, based on these futures, we call them, right? All of these are our X. We want to predict the quality. The quality is a number. Based on this, we see 5. So maybe we have 1, 2, 3 like that. If we see the last 5, we see we have 5, 6, and whatever. We can do all other things. Describe.info.shape to try to understand our data. You can try that on your own. So we have to define our X and our Y. You know, that's normally anytime you want to do machine learning, remember, keep in mind, you have X and Y. You are always trying to predict Y, right? So what are we trying to predict? We are trying to predict our quality. So our quality is our Y. So we see Y is equals to, from our data frame, to pick the column of quality, right? So, and every other thing is our X. So how do you do that? We just say from our data frame, we drop quality from our data frame. So we have our X and our Y. If we have just two values, only one, meaning only last week we saw example with only one example, only one X. So we can just assign that to it. But here we have all of these cells are our Y. This is introductory class. We can do many other things. We can, for example, do feature selection to determine if all of these features are even important in our classification, but forget about that for now. So we are picking everything as our X and only quality as our Y. We've done this, and you remember we have our Y is equals to mx plus c. So Y is what we want to predict. It's a prediction. So it's the quality, and every other thing is our X. Yes. So we already have scikit-learn installed in our environment. Okay. So we need to import the things that we need. Remember, so just all the time, most of the time you will be doing your thing, we have to import this train split, because normally when we want to evaluate our model, you remember we see we have to divide the data set into training set and test set. We've done this last week. And then we import our models. So we have many of them. So we are doing regression. We actually want to do this. So linear regression one, we can have decision tree. I don't know if I've explained decision tree last week. It just uses a tree structure. For example, you want to predict, but this is classification, yeah, but let me still explain it in the classification form. If a person is a boy or a girl, you can use the properties based on maybe height and weight. Is height greater than a certain number? Yes. Then you go to another classification. Is kaza using if statements. Actually, simply use if statement. A number of if statement conditions are met, you determine which side to go on. And then we have the random forest regression. It's also another form of decision tree, but it has multiple trees instead of just one tree. And then we import the metric for our evaluation, which is mean squared error. As I've explained to you, we use many metrics for regression, but it's always error. So it can be mean squared error, root mean squared error, relative absolute error, and all of that error matrix. So the first thing to do after we select our X and our Y, or we define our X and Y, is to split it. You remember I tell you all the time, I explained this last week, all the time you want to do regression, you have to split your data. You have to create 4 variables that you need. You need your X train, X test, Y train, and Y test. And I explained to you what we use them for, especially your Y test. So you use this method. So you don't need to memorize this. You can have it somewhere on your computer. Anytime you want to use it, you just use this. The only thing that you have to, your X and Y need to be consistent. So here you put X and Y. Here I don't have to say X, I can say A and B. But if I say A and B here it has to be A and B. Yes, last week I think we used capital Y here. So you can use capital Y. You have to be consistent. So whatever you have here as your X and Y is what you have. Then you determine your test size. So as I've said, you can use test size or you can use train size. Yeah. So equals to, so we can use train size as 0.8, but if we use train size, then we are not going to use test size. So we can use only one of them. So train size is equals to 0.8, meaning we are going to train with 80% of our data set. Automatically, if you define your training set, then the remaining will be your test set. If you define your test set, the remaining will be your training set. As I explained to you, we mostly want to, as I've explained previously, we mostly want to, uh, please pardon me if I speak too fast. You can call my attention to speak slower. I tend to speak fast. So we train with as much data as possible, keeping in mind we need sufficient also for evaluation, for testing. Yeah, so generally you can use 80%, especially if you have a large data set. But if you have a very small data set, then maybe you can go to maybe 70-30 or even 60-40 if it's a small data set. But generally you want to do, you need sufficient data for training, otherwise your model will not learn anything and your result will not be that good. So similar to what you've seen previously, we define our, you create an instance of a linear regression class if we're using linear regression, and then if you create an instance, then you can just use an instance of it. And how you do that is you fit your model. So you use what? Um, okay, maybe even though many of you are not old, but maybe I should increase the size. Maybe I can, how do I close this? Maybe this is better. Yeah, so we fit the model based on what we created here. Here it's not compulsory that you have to use these variable names, but you need to be consistent. Whatever you put extern here, whatever you put here, it has to be what you have here, extern and x test. So, but just use it as it is for convention. This is the convention used, so just maintain the convention. So you have that, and then after you fit your model, the next is this is the training. So the next is you make a prediction, because if you do not make a prediction, you cannot know if your model has done well or not. So you define a value for to store your prediction, then you have your prediction, and then finally you get your you evaluate it based on your actual values of your y test and then the prediction that you made. We did all of this exactly last week. Then lastly, you can print your mid-squared error. Right, so like I've seen, yeah, seen a comment. Yeah, so this is for linear regression. And then when we want to use a different model, it's exactly the same thing. The only thing that will be different is the name of the model. So the next one is decision tree, and it does exactly the same thing with just this variable random state. You can put any number, so that because your decision tree create trees based on certain uh, calculations. So you want that to be replicated. If we don't use this random state, there may be slight difference in what it does. So we want it to be consistent so that we can replicate our results. This is just to be able to replicate your results, not that anytime you run it, you have a different. Sometimes you notice when you run some models, you have slightly different results or different on a different computer. So it's because of this random state that, and it's the same thing that we use here. If we use this random state, we are ensuring that how we split the numbers we pick in different split is it remains the same anytime we run the model. Anytime you see this random state, we're trying to maintain the parameters used in creating that model or creating that function, whatever happens there. And random forest, because it's also based on decision tree, so we also need to define that. And then at each instance, we can see the results. So yeah, so you can see we have okay, a question. But now you can monitor the questions. And then get them to me. Which is the best model? Based on these results, which is the best model? Maybe you did raise up your hand before you speak. I don't know. Random forest. Okay. So why is it the best? Only two people answered.
Random
We have,
forest
huh?
because it has the lowest error, sir.
Yeah, because it has the lowest error. We remember if we are doing regression, smaller is better. So the smaller the error, yes, the smaller the error, the better our model is. So, and there are many other things that you can do here. You can try to find out, for example, even though a decision tree and random forests are all based on, they have similar architecture, they're all decision trees. Why is the disparity? What we have done differently and all of that. So I don't think there is many other things that I can tell you about regression. So this is the basic. And then next week you would do classification with Dr. Shamsuddin. Um, but because we finished early, maybe I can just go ahead. So the only difference between classification and regression is in classification we have distinct classes, meaning we are not predicting a number, we are predicting a distinct classes. So let's look at, for example, if we have a desert like this that have about a flower, and then it has these properties. So based on your question, yes, based on based on this result, random forest is the best model because it gives us the best result. But this is keep this in mind. That's how it is generally. But this is premature. There may be many things that you could do differently. So um, generally, building model is not this simplistic. This is the most basic implementation. There are many other things you can do. Adjust your features, parameter optimization, and all of that to ensure that you have your best model. But as far as this case is concerned, uh, random forests is the best. And generally, random forest is better than decision tree. So this I can tell you because random forest is a better version of decision tree. So it will be very rare to find a situation. It's very rare to find situations where decision tree will beat random forests. Yeah. So and what it can tell you, another thing you can conclude here, for example, is you can see the data is not too much linear, because if data is absolutely linear, then probably linear regression should have performed the best. Yeah, so there are many things you can see, but just take this as introductory and continue playing around with the things you have. So we have this data set, for example, of flower, the length, weight, both the sepal and the length, and then we can see which kind of flower is it, whether it's iris, setosa, or whatever. So this is a classification problem. But what we are going to do here is it's exactly the same. Just define your x and your y. Your y is always your class, and then your um x is all the remaining other variables. Then you split your data set into x, whatever, exactly the same thing we did. And then you define your test set. Okay. Shamsuddin will tell you more of this. I will not waste too much time. But let me go back to our data set. Okay, maybe I even explain a bit of this. If we look at this data set is not on the same scale, meaning the range of values for the different columns are different. You can see here we have values in the range of 0 points to 2, for example. And and here we have 5, 6 point whatever, they are in different scales, and we can have a data set that have completely different scale. So if you want to use these features, all of them, not one, if you want to use all of them for your machine learning, you have to convert them to the same scale. Otherwise, your computer, your machine learning will assume they are on the same scale. So one way to do that is use a standard scalar from the scalar library, and then it's easy. You just import after importing it, you can create an instance of the class, and then you just fit your X string, which was your X string and your X test with the standard scalar, so that you scale everything, meaning all of them will be on the same scale. So that is it. Anytime you want to do any machine learning and your data is not on the same scale, you have to do scale. You have to normalize your data. We sometimes see normalizing your data, and then you can use any of the classification algorithm. Yeah, so in this instance, for example, we are using the KNN. I explained to you last week what KNN is, the neighbors. With determine, we specify the number of neighbors, and then we just do it exactly the same as we did in regression. Here we are using logistic regression. We have the accuracy. Remember, for classification, we have accuracy. The higher the better. So your accuracy is, we want 100%. So 0.9 is like 96%, which is very good accuracy. And then this is spec2 machine. It's all the same model, just the same problem, using different algorithms. We have SVM, which perform the best, using like having an accuracy of 100%. So these are some points. I will share this notebook with you if you'll find it helpful. It has more examples than what we have in our GitHub repo, and we'll update that our repo to have this. So you generally need to import all your libraries. You need to import your data. This is not compulsory, but you need to visualize your data to understand which kind of data you have. You pre-process your data. The scaling we do is pre-processing, but not just that. For example, you need to even selecting what you need, X and Y, is all pre-processing. You define your dependent and independent variables. You split your data into trainer and test set. You fit your model. You predict and you evaluate. So this is a long list, but it's quite simple. So you need to. These are the general steps, and it's easy. Library, data set, and all of things that you can do. And then the libraries that you use in machine learning, NumPy, Pandas, Matplotlib, and then the most important of them all, scikit-learn. Yeah, so Balab today will share this notebook and the dataset with you if you want to practice. Not so he will do more of classification, a detail of it with Dr. So this is just a quick, but actually classification regression, you can do them in one. We can just do them in one lecture. They are basically the same thing. The only difference is that how we evaluate the model. In classification, we use accuracy, precision, recall, and maybe F measure. And in regression, we use error metrics. And yeah, probably Shamsuddin will also explain to you about how we determine the, let's see, accuracy is easy, it's straightforward, right? The percentage number of instances that are correct. Then how you get your precision and recall and F measure, you based on what is true positive, true negative, false positive, and false negative. You will do all of that. So Any question?
Yeah, thank you, Dr. Ibrahim. So this marks like the end of our regression session. So we'll dive in next classification. And also, if you do have any question regarding the regression, please do reach out in the channel. So generally what we intend to cover in this machine learning is three things. We intend to cover regression, classification, and clustering. These are some of the three major stuff you will see in machine learning, all of these. So we'll cover them. So after we cover them, then we can take a little bit like application of all these machine learning stuff. For example, we can take and do sentiment analysis, which you'll be able to classify sentiment. So the first thing is to do regression, classification, clustering. Then the second part is to take at least application of all this in the real life application you see. For example, machine translation. So we see machine translation, we see sentiment analysis. So that's now this first part is just seeing how this algorithm works. Then we'll be able to see next week and cover the details of. Let me share my screen. Can you make me a host? So that I can.
So which account? Okay, this one. Yep, we should be able to share screen now.
All right. Okay. Can you see my screen now?
Yeah, it's visible.
Okay. So what I'm saying is that you can see we have introduction, which I already covered. Then we can have regression, which Dr. Ibrahim now covers. Then the next one is we're going to have classification. Then we're going to have clustering. So these three things, regression, classification, and clustering, all the machine learning you'll be doing may fall into these three categories. You are either doing regression if you are predicting values, right? So if you are doing predicting value, for example, what is the price of the house in Abuja? You are predicting if it is in, has three bedroom, you are predicting is 2,000, is, 2 million, 3 million. You are predicting continuous value, then you are doing regression, right? If you are doing classification, if you are given, for example, given this data set, tell us whether this is hate speech or not hate speech, you are doing classification. Clustering is when you are given, in an unsupervised way, you are given data set, given some information to cluster them into different classes. That's clustering. Then when we cover this one, then we're gonna dive in and take a little bit of, a practical application of all these in one. So here, for example, we're gonna do NLP, which is using text to do machine learning. We're gonna do, for example, machine translation, you can see here. And then we're gonna do time series, and finally we're gonna do reinforcement learning. So what I want to emphasize now is that we have few weeks to not maybe like 4 weeks or 5 weeks. I think we already cover now 3 weeks. We have 5 weeks to complete this machine learning. What I would encourage from now on, we understand some of you are still lagging in the data camp. Some of you are doing consistently good. We are monitoring. So we now come up with plan whereby each and every week now, from now to end, you will be submitting your completed certificate from data camp from the data scientist with Python track we already put you in, to make sure that you are in sync up to the final part of the this ROD. Yes, we don't want a situation whereby we say, okay, next week we are going to complete this program. Then you see people, trying to finish all the courses at once. That's, you are not learning. What you are doing is you want to get certificate to pass. But what we want you is just to learn. Just learn every day. Just spend like 30 minutes, practice, 30 minutes, practice. That's what we want. Just to, infuse this kind of, consistency, because what makes you perfect is consistency. Without consistency, you'll never become good and perfect in anything. But with consistency, no matter how little effort you put daily, trying to muzzle your, memory skills. That is the only thing that, becomes, makes you to become excellent at whatever you do. So we'll reach out to you in the Telegram to tell you more details about our expectation, what you need to submit. We do expect at this point you already finished like maybe the first 3 data science track courses, and we will send you a form to submit your certificate for all those stuff. That is that, and your mentors will be following up to make sure that you submit all these data science stuff. We also, as you can see right now, we haven't been asking you to do blog Medium and whatsoever, because we thought with machine learning, with the data come, you are engaged, but it turns out that you are still not engaged. You have not been, because we can see who are doing this, who are not doing this from our own end. We can see everyone. So we'll, send more detail about this. And so that's what I want. So if we come, for example, for classification, let me highlight what we are going to do. So this is classification. Please try to go through this. You'll communicate better when you go through. So we'll introduce classification, as I already made mention, is, this is an example where you can have spam or not spam. So assume you receive an email and you want to classify this email, whether they are spam or not. So this is an example of classification, right? So we're going to dive into classification. And here, for example, at times you may receive data set that is not balanced. So let's assume I want to do hate speech detection. And then you are doing supervised learning. You need a data set that is pre-level with something is hate or not hate, right? Before you train. So when you have your data set is unbalanced, so maybe you have 3,000 data set, but you have about 2,800 or 500 that are super level as hate and 300 that are not hate. So you can see the data set is not balanced. We'll discuss all this stuff. I'm just telling you what we'll be doing. Interestingly, in this session, for those that are interested, we will have something at the end, which is you're going to build a recommender app. You're going to build a recommender app. What this means is that by the end of this session, you'll be able to build a machine learning model that, do some kind of recommendation. For example, if you check refrigerator, you have a refrigerator in your home. You check, okay, in my in refrigerator, I have this one, I have this one, I have this one. Then you can click what kind of cuisine can you recommend. Then you see recommendation. So this is what you are expected to do at the end of this. But because we acknowledge some of you may not have experience with HTML and other stuff, that may not be necessary, but we highly encourage any one of you to try to practice to see that you can be able to build your machine learning model, even a browser to serve it. So yeah, this is something that we're excited to all of you. Our previous cohort, some of them, they don't have experience with this, but they were able to, implement this, and we will encourage you. So we highly encourage you to read this before our next week's session to dive into this. So any question before that?
Before the questions, Doctor, I don't know if Bala has been following on this. We shared a survey with you regarding, we call it they call it from Google, what do you call it? Pre-survey, right? All of you have to fill it, that survey. So I don't know if Bala has been reminding you. So Bala, please, can you say something about the survey?
Yes, I do follow them. So I expected by this moment everybody have feel it.
Okay, so unfortunately we will not be able to. Okay, yeah, I will verify it, and then we'll see what happens. Go ahead, Doctor.
All right, thank you very much. Maybe this may be a flow for anybody with question or some suggestions.
Assalamu alaikum.
Wa alaikum salam.
Good afternoon, everyone. Good afternoon, Doctor.
Yes.
Yeah, so my contribution regarding working with data camp and completing some of us have actually been trying to work hard to complete it. So I just think you said there's going to be a something that is going to be released for us. I'm just thinking that the expectation should be a little bit like reduced, because a lot of us we have other engagement in terms of like this time around the Ramadan and everything, but that doesn't mean we've not been engaging. For instance, for myself, I've been trying to engage the material, but I'm just saying that that should be taken into consideration of what we have been doing and the fact that this period that we find ourselves in.
Yeah, thank you very much. Yeah, so we do understand and also recognize like people are engaged and other stuff, but the issue is like some of us here, which are fellows, have not even completed the first course in the the data cam, which is something that you already did. So that's why we want to put it like a way in which sometimes if you don't push people, you don't give them deadline, you don't ask them to do, you just leave them like that, they will not do. You know what I mean? So what we are trying to say is that we'll put like a kind of thing that can actually motivate people to do. That's it. For example, if we just allow everyone, trust me, we will come to the final week of this RODS and a fellow is following, but he has not completed even at least one course. So we as organizers, how can we help such fellow to make sure that he is in sync? He's following the timeline and also he's not like behind. Because like this is not university, like if you don't come, if you don't, we cannot do anything for you. But we want to help you to push you forward because we care about your, about your learning, and this is one way to push people. So thank you very much, but we'll make sure that we take consideration about this is also fasting period and people have other engagement and commitment. But we already have Lukman. Lukman, he's a mentor, and Lukman has already finished all these courses. He's not even a fellow, but a mentor, but he has finished all. It's really amazing to see how Lukman, he's like, doing all this stuff. Somebody was asking me, does Lukman doesn't have a job doing? I said, oh no, Lukman has a job also doing. He's like, he has a full-time job, but on his spare time, he's trying to see, he put this in practice. And trust me, like this kind of consistency and practice, that's what makes you better at whatever you do. Yep.
To reiterate, we want, and I'm sure you also want to continue benefiting from this kind of thing that ordinarily you need to pay money, but you are benefiting for free. You want to benefit and you want others in the future to benefit. And the only way we can do that is to ensure that we are completing the courses that we enroll so that DataCam can see that they are making an impact and we are making an impact. Otherwise, it becomes not very useful to facilitate it, and then others will not benefit. So we understand the restrictions, but you have to keep in mind completing the program is a very good step in ensuring that you benefit in future and others also benefit. Thank you.
Also, we would like to highlight that at the end of this program, we will recruit some of you to become also mentors for the next cohort, because now we are at the tail end of our RODS. In the next couple of 4 or 5 weeks, we will end it. So please, if you happy to be considered as a mentor in the next cohort, please reach out. We also reach out to people that we see how good they are, how, of course, we have seen people that are good in our cohort. So those people will reach out to them automatically to become our mentors in this, because this is the, spirit of community, right? In a community effort, it's where people comes together, right? Try to see how can they improve their immediate community. One way is to give knowledge you have, right? You don't know one day what will happen to that person. And you know, I mean, my greatest happiness is see that we come and contribute and help one another as a community. So please feel free, if you want to be a mentor, immediately after the session, reach out so that we can you know, rope you into and onboard you into our mentors group so that you can also be part of mentor. Right. So now we are on top of the hour exactly right now. So thank you very much for joining us. If there is no question, we can see tomorrow, inshallah. Bye-bye.